Math 3 1-22, we're being asked to make a complete graph of this function. And if you remember, a complete graph includes lots of exact points, precision in terms of the graph. I am going to let you take that piece on, but because we do need some complete points, we're going to work on choosing inputs and outputs that work for this particular function. Notice we have a square root of x minus 2. We can be very strategic about the values of x that we choose as inputs in order to make this a little easy on ourselves. I am going to choose values of x that are perfect squares, so that when I take the square root of x, it, by just the simple ease of it, is an easy math, okay? So I know that 0 has a perfect square, so the square root of 0 minus 2, 0 minus 2 is negative 2. Alrighty, and I know that, let's see, 1 has a perfect square, so let's choose 1 as an input. Square root of 1 is 1. 1 minus 2 is negative 1. Okay, so you kind of see the pattern. So the next perfect square is 4. So the square root of 4 is 2. 2 minus 2 is 0. And the next perfect square is 9. So the square root of 9 minus 2 is 3 minus 2, and 3 minus 2 is 1. So you kind of get the idea on how to be very strategic. When you set up your graph for this particular problem, be very, very careful. Make sure you have a strong labeling x and y axes, and be very specific on your points. Function like this is a continuous graph, so you will connect the points and include an arrow to indicate that your function continues forever.